Let's back up. So again, thanks to the First Street team for having us today. Really appreciate this opportunity. Really enjoying working with the First Street data. Thank you for making it available and enjoying the community of researchers that you all are pulling together with the Flood Lab. So my name's Jake Bradt. I'm here to talk today about some work that I'm doing with co-authors, Carolyn Kousky at the Wharton Risk Center, whom I believe is on this call, and Ollie Wing at the University of Bristol, also at Fathom. And in this work, we're looking at sort of holistically examining the market for flood insurance in the US. In particular, we're interested in better understanding voluntary insurance purchases and drawing out insights about this particular segment of the market that might shed some light on the impacts of some upcoming reforms to the National Flood Insurance Program. So before I jump in, I'll just say, this presentation was initially planned to be 20 minutes. So I'm still sort of going to target that, but since we have a little more time than initially planned, encourage folks to jump in as we go along. I've got video up, so I'll try and recognize raised hands, but feel free to just sort of chime in with questions or comments as we go. So, probably not necessary for this group, but still want to sort of set the stage for this work. Flood-related events are responsible for the most damage in the US out of all natural disasters. For example, flood-related economic losses totaled just under 300 billion in 2017, which is the largest flood-related loss year on record. And not only do floods currently represent a significant share of damage from natural disasters, but these risks are intensifying in many places due to various factors, including the increased intensity and frequency of significant rainfall or storm events, as well as sea level rise. Now, in this context, there are a couple other facts to make note of. According to the Federal Reserve's annual report on the economic well-being of US households, the vast majority of homeowners in the US lack access to sufficient liquid funds to pay for rebuilding with savings after these kinds of disaster events. And with, contrary to popular opinion, with federal disaster aid relatively limited and inconsistently available, we view insurance as typically being necessary for a full financial recovery from these events, which are becoming increasingly important. Indeed, a paper by my co-author, Carolyn, a recent paper found that those with insurance recover from disasters better and faster than those without. Now, flood is not usually covered under standard property insurance contracts. Since it was introduced in the late 1960s, the National Flood Insurance Program has been the primary underwriter of flood insurance in the US. Recent estimates suggest that the National Flood Insurance Program, which is housed within FEMA, represents around 96% of all residential flood contracts in the US. This has important policy implications. The fact that the federal government backs the majority of policies in the US implies that it bears the bulk of all flood risk in the United States. In recent years, large claim events have threatened the fiscal solvency of this public insurance program, with total claim events resulting recent claim events resulting in total debts exceeding 20 billion in recent years. In addition to underwriting the majority of residential flood insurance policies, the NFIP publishes flood insurance rate maps, and you can see a snapshot of one such map on the left here. This is focused on the campus of the Kennedy School here in Cambridge. Not a terribly interesting example as far as rate maps go, but you can see if I imagine most folks have, but if you haven't seen these before, looking at this example gives you a sense of the kind of information communicated in these maps. In particular, these maps delineate the spatial distribution of flood risk within communities, and in so doing, they dictate the rates at which flood contracts are available through the NFIP, the National Flood Insurance Program. Now, an important distinction in these flood insurance rate maps that I want to draw your attention to that's going to be important for our study is between special flood hazard areas, which are areas with annual inundation probabilities greater than 1%, and non-special flood hazard areas, which have a lower annual inundation probability. Importantly, for the purposes of the National Flood Insurance Program, homes within these special flood hazard areas with mortgages from federally backed lenders or federally regulated lenders are required to purchase flood insurance. And typically rates within these areas vary relatively coarsely with property level risks. Certainly more so than those available outside the SFHA, where there's relatively less variation across policies in pricing, and generally prices are lower in these lower risk areas. But on the whole, the NFIP provides pretty large implicit subsidies to homeowners in the form of below actuarially fair premiums and outdated flood maps. That's an important fact to think about as we look at our study context here. One last thing to note, despite the fact that there is this mandatory purchase requirement, it's relatively poorly enforced. So take up of insurance within special flood hazard areas is not 100%. We estimate using data from 2019, it was around 50% nationwide. But that said, it's relatively higher, take up is relatively higher within special flood hazard areas than outside. We estimate outside special flood hazard areas nationwide in the US, the take-up rate in 2019 was around 2%. But of course, flooding is not limited to the 100-year floodplain. And in fact, looking at NFIP claims data between the late 70s and today, we find that almost a third of all claims come from outside the special flood hazard area. And in recent years, as you can see here, certain high loss events have resulted in a large share, much larger shares of claims coming from outside the SFHA. In recent years, up to and exceeding 60% of annual claims have come from these lower risk areas. And also the share of total policies in force outside of the SFHA is increasing. So the point that we want to make here is that this is this voluntary segment of the National Flood Insurance Program, these areas outside special flood hazard areas, clearly, is substantial in its own right. It's non-trivial and plays an important role in this market for flood insurance in the U.S. And so understanding the drivers of voluntary purchases in these areas has an important role to play in ensuring not only greater individual level financial resilience to increasing flood risk, but also in the overall fiscal solvency of the NFIP. So, despite the fact that these contracts, these outside the special flood hazard area contracts, play an important role in this market, much of the prior work examining the National Flood Insurance Program, in particular looking at demand and take-up under the National Flood Insurance Program, has focused on areas within special flood hazard areas as these higher risk areas, or sort of at larger aggregate geographies, not necessarily distinguishing between these two segments of the National Flood Insurance Program. You can see we cite to a few papers here, certainly not an exhaustive list. Apologies if there are any of your own or that you're aware of that we're missing here. But our project is intended to provide a more holistic examination of the market for flood insurance in the US by specifically looking at demand, not only within these high risk areas, these special flood hazard areas subject to the mandatory purchase requirement, but also these lower risk areas not subject to this requirement, these areas outside special flood hazard areas. And in particular, we're interested in learning more about what correlates with voluntary take-up, of what correlates with what factors are associated with greater demand in this voluntary segment of the NFIP. And we'd also like to learn a bit about how homeowners' willingness to pay for insurance and the cost of providing insurance to these areas varies outside the special flood hazard area. And in so doing, we hope to shed some light on how some planned and potential reforms to the National Flood Insurance Program will affect the overall market for flood insurance. And in particular, we'll hopefully get to this at the end. We think our findings are going to have some interesting implications or raise some interesting questions about some upcoming reforms that are planned to take effect in October of this year, collectively referred to Risk Rating 2.0. So to preview our results, we use historical NFIP policy and claims data to examine aggregate demand for special flood hazard area and non-SFHA policies at the tract level. So we're going to focus on aggregate demand at an aggregated geography. And we'll get into the reasons why we do that in a moment. But what we find is that there's interesting heterogeneity in take-up on household characteristics. We find some interesting aggregate correlations in the data that we put together. We also find that there's a non-trivial response to salient flooding events in take-up outside of special flood hazard areas that we don't necessarily observe in these higher risk special flood hazard areas. We also use some policy variation to estimate price elasticities and find that demand is relatively more elastic outside of special flood hazard areas. And we also use the claims data with the policy data that we analyze to find suggestive evidence that homeowners are selecting into insurance based on unpriced risk. And that's where the value of the First Street data, that at least for our project, is really going to come into play. So with that setup and a preview of our findings, I'll go ahead and jump into our methods, and again encourage folks to jump in as we go along with any questions. But to start off, I'm going to discuss a little bit about our approach to analyzing demand that I alluded to earlier. But first, to give you a sense of the data that we're going to use, I imagine folks are at this point quite familiar with this data. If you haven't used it yourself, you're probably aware that it's out there. But since I believe a couple of years ago, FEMA has made available the universe of transaction level policy data on NFIP policies dating back to 2009. And so that transaction level data is what we're going to use to construct take-up rates at aggregate geographies. And we'll talk about how we do that in a moment. These data are quite rich if you haven't used them already. Just to go through sort of what's included in these policy data. They include things such as coverage amount, the premium paid, the flood zone of a policy, and a host of other relevant and interesting contract attributes that we are going to use, and many that we don't use. So, just scratching the surface of what's in these data. Now, unfortunately, it's not possible to explicitly link policies over times or explicitly link claims to policies for various reasons. I imagine perhaps there are some data privacy concerns. Regardless, there is not a specific ID field that can be used to link policies. Over time, policies are recorded as each for each property, a single year's length of policy. That these policies are typically written over the period of a year. So for a specific property, a single year's worth of coverage is recorded as a separate entry within these data. So we're not able to explicitly link these. Some have been able to do sort of a fuzzy link over time, and part of what we're doing moving forward in this work is seeing if we can replicate some of our results, linking these policies over time, and then sort of looking at an individual level, seeing if some of our primary results still hold. But So, one point to note is that these can't be linked over time, and we're not able to link policies to claims. Also, the geographic data contained in these data are relatively coarse. So we can only identify policies by geography down to the census tract level. So in light of these two aspects or attributes of these data, we focus our analysis on studying insurance take-up rates at aggregate geographic levels. And doing so has a number of helpful features. It eliminate we're able to get around some of these issues with the ability to link policies over time and the ability to link policies to claims. It also, examining take-up rates is nice because we actually can interpret take-up rates as telling us something principled about total demand on the extensive margin within a geography. In particular, it's possible to interpret these take-up rates, and we do, as average choice probabilities, where the choice is over whether or not to purchase insurance. So average average choice probabilities across a given aggregate geography. Now, to calculate these, there are a couple of additional things that we need to know. And in particular, we need to know the relevant size of the market. And so we choose to focus at the census tract level since it's the finest geographic information contained in the policies and claims data. If we were just to stop there, it's perhaps relatively trivial to calculate these take-up rates. The Census Bureau releases annual estimates of housing unit counts, which would define the size of the relevant market at the census tract level. However, what we are trying to do in this work is separately examine take-up within special flood hazard areas and outside of special flood hazard areas. So in reality, what we actually need is not just an estimate of the count of housing units within a census tract, but we actually need that by non-SFHA and SFHA areas. So we need counts at the census tract level of housing units within special flood hazard areas and outside special flood hazard areas. So to do so, we follow a method that we found used by the NYU Furman Centers, and it's has certainly some limitations, but we're certainly open to other thoughts that individuals might have on how to go about doing this. But this is the particular approach we took to address this issue of estimating the denominator and calculating these take-up rates. So what we do is we take geographic data on census block bound geographies. So census blocks are subunits within census tracts and are relatively small geographies. And what we do is we take the centroids of those census blocks and interact them with nationwide flood insurance rate maps. And in so doing, we can assign to specific census blocks non-special flood hazard area and special flood hazard area designations. And then what we do is we aggregate those, or we take housing unit counts at the census block level and then aggregate up to the census tract level, the non-SFHA and SFHA housing unit counts. And then we construct annual tract by flood zone counts of policies in force, which is going to serve as our numerator. And with following this method, aggregating up by census blocks, we're able to estimate the denominator and calculating take-up rates by these different geographies. So this has some nice features. It allows us to separately examine these aggregate demands by zone, by non-special flood hazard area and special flood hazard areas. But there's certainly some downsides. Importantly, the denominator is static. We're using housing unit counts at the block level from the 2010 census. And I think there are a number of ways in which we could describe the potential for measurement error here in doing this kind of aggregation. So, we like our measure of take-up rates tracked by flood zone take-up rates, but to test the robustness of our measure, we also use policy in force counts, where we normalize the policy in force for each tracked by zone area to a given year to address the fact that there could be potentially quite large values driving our results. So in terms of analyzing these take-up rates, again, we're interpreting these as sort of aggregate or average choice probabilities. What we're interested in are these the sort of how these vary along different socio-demographic lines, and along with a number of other covariates. And so what we're generally going to do is run regressions of the form take-up rate on a set of time variant and time invariant tracked and tracked by zone attributes. And we'll control for unit and time unobserved effects using various levels of unit fixed effects, as well as annual time fixed effects. And this is a specific functional form assumption. We're going to test our results, the robustness of our results, to an alternative assumption where we model these choice probabilities, or these take-up rates, as fractional response probits. I'm not going to highlight those results here, but I believe I have a few of those at the end if folks are interested. So what are the covariates that we're going to look at? Well, there are two sets. They're a time varying set and a time invariant set. In particular, from the policy data, we have average policy premium, average CRS discount, which is going to play a role in determining individual policy amounts by zone and tract. We also, at the tract level, look at a number of homeowner and households characteristics, which we take from the 5-year American Community Survey estimates from the census. We're also going to look at or bring in data on presidential disaster declarations, individual assistance funding through FEMA, and information on high precipitation days. This will give us some interesting results about the impact of salient flooding events on take-up that we're interested in looking at. Some time invariant covariates that we're going to look at are the First Street flood factors. These are going to be quite interesting as we start to look at the potential for selection in these markets, and we'll get into that in a little bit. There are also some geographic attributes that we condition on, and our full panel is going to look at the years 2009 to 2019. So I'll go ahead and get to some results. I've been spending a fair amount of time on setup, so here's the fun part. So looking at correlates to take up both outside and within special flood hazard areas, we're going to start by taking a look at some interesting homeowner and household attributes at the aggregate level, and see how these correlate with aggregate take up. And we find that education is positively correlated with take up, both outside special flood hazard areas and within these special flood hazard areas. We also find that household income correlates relatively highly with take up in both zones and special flood hazard areas and non-SFHAs. Age also positively correlates. So this is what we're showing is the share of a census tract under 35. So a greater number on the x-axis is going to imply on sort of aggregate older population. We find younger population. We find take up is lower when the share of younger individuals is higher in census tracts. And then looking at the share of households with a mortgage, we find little evidence of any relationship between the share of households with a mortgage and take up outside the SFHA, and a positive relationship within the SFHA. This likely is being driven by this mandatory purchase requirement. So some interesting correlational results here, some that validate previous findings on insurance take-up in the literature, and perhaps may be of interest to policymakers. Some other interesting correlational findings that we find. The occurrence of a salient flooding event, which here we're showing as the occurrence of a relevant presidential disaster declaration, which we define as related to a flooding or a severe storm, a flooding event, severe storm, a coastal storm, or a hurricane. We find showing that here estimates in sort of an event study framework, suggestive evidence that take-up outside of special flood hazard areas is influenced by the occurrence of these salient events. Less, a bit noisier evidence outside within special flood hazard areas that these these salient events have meaningful impacts on take-up. Importantly, what we're also conditioning on the amount of individual assistance funding received at the tract level, excuse me, in these disaster events. So it appears as though conditional on the amount of assistance funding received in these events, there does appear to be some sort of informational communication, particularly outside of special flood hazard areas in these events. And we sort of replicate this, not in an event study framework, but using lagged presidential disaster declaration counts and find similar results. We also use NOAA's storm event data to replicate this and find roughly similar sort of impacts of these kinds of salient events on take-up. So to keep moving here, just check time, okay. So we've shown some interesting correlations, which I think can look to, I think we interpret more as interesting empirical facts that tell us a bit about what kinds of factors are associated with greater aggregate take-up. But when it comes to really understanding what is going on in this market and these two segments of the flood insurance market, particularly when we want to think about the impacts of planned and potential market reforms, there are a couple of parameters that we want to think about being of interest. In particular, homeowners' willingness to pay for insurance and the cost of provision of insurance in these markets. So, we take care to control for a lot of, a pretty rich set of observables of interest that from previous literature and sort of institutional knowledge suggests correlate with insurance demand, but it's still certainly possible that prices are going to be endogenous in this setting. Insurance policies that all else equal are more desirable, perhaps by offering greater coverage, are likely to be more expensive. Also, and certainly within special flood hazard areas, policies for high-risk properties are more expensive, while at the same time, higher risks may increase demand. So, to really, in a principled way, estimate price elasticities, estimate willingness to pay, we need to and do isolate policy induced price variation that's uncorrelated with demand determinants. And to do so, we're going to use two specific reform events within the period for which we have data: the Homeowner Flood Insurance Affordability Act in 2014, and then the Biggert-Waters Flood Insurance Reform Act of 2012. So in the case of non-special flood hazard areas, we're exploiting the exogenous variation in the relative price between primary and non-primary residences that was introduced by this 2014 reform, this Homeowner Flood Insurance Affordability Act. And this differential was introduced in the form of a new surcharge to aid in the fiscal sustainability of the National Flood Insurance Program. The amount of this surcharge, which started to be assessed in 2015, is $25 for primary residences and $250 for all other properties. Given, where's the bulk of historical policy and legislative reforms to the National Flood Insurance Program rate setting structure apply only to the special flood hazard area policies. This differential that was introduced in 2014 applies actually to all policies. So it's if you've studied this, there are very few examples of policy-induced variation outside of special flood hazard areas. This is one, not a perfect example, but it's one of the few that we were able to find that gives us some plausibly exogenous variation in non-special flood hazard area rates. So to account for the endogeneity of the share of non-primary residences outside the special flood hazard area after the introduction here, what we're actually going to do is in instrumenting for non-special flood hazard area prices is fix the share of non-primary residences outside of special flood hazard areas at the tract level to the year 2014. And then interact that with an indicator variable for the year being 2015 or greater, and use that as our instrument. And to be precise, what's the identifying assumption here? Plausible or not, I think that could be up to debate. We certainly see a noisy but decent first stage here. The idea is that this differential surcharge is the only factor that's going to be differentially affecting non-primary and primary residences outside of special flood hazard areas in 2015, importantly, conditional on our covariates. So to talk through what we use for the special flood hazard areas, what we do is we're exploiting variation in the relative price between pre and post flood insurance rate map homes. So these are homes that were were built before and after flood insurance rate maps were first written in a community. And so the bigger water reforms in 2012 introduced or removed a lot of discounts that areas built before flood insurance rate maps were written in a community received. So this reform changes differentially the price of pre and post firm construction homes. And this is interesting variation that's been utilized in other work. Carolyn Wagner has a paper that uses this, looking at special flood hazard area demand. And we're going to, again, to account for the potential for the fact that pre-firm homes are going to face higher prices following the reforms, and are going to be more likely to drop out after these reforms. We're going to fix, in constructing our instrument, the share of post-firm homes outside of the special flood hazard area to the pre-reform year 2012, and then interact that with our time indicator variable indicating the post-reform years. And so what do we get in terms of results? So this table is showing you comparing what we get without instrumentation and with instrumenting these policy premiums. We find generally that the OLS estimates were biased upwards, more so with special flood hazard area take up, where we estimated a positive coefficient on price in the OLS estimates, and with the instrument using the bigger water reforms in the pre and post firm pricing differential, we actually do estimate a negative price coefficient, which we would have anticipated sort of as a prior. And in terms of the elasticity estimates that we get from our instrumented results, which are our preferred results, we find that there's weakly greater price sensitivity outside of the SFHA, though these are relatively small elasticities, but nonetheless some greater price sensitivity outside of special flood hazard areas. And I should say these are roughly in line with previous estimates of price elasticities. I think the Carolyn Wagner's work estimates roughly similar, around 0.2. So lastly, I'm sort of almost at time, but I want to show you the last set of results that we look at here. particularly focused on the potential for selection in these markets. So the coarse nature that I alluded to briefly at the beginning of the National Flood Insurance Program rate setting structure, particularly outside of special flood hazard areas, gives rise to the potential for adverse selection. In particular, since pricing is so coarse, it's possible to imagine a situation in which homeowners have access to better risk information than is reflected in their insurance rates. And so if homeowners have access to this kind of information, that might drive individuals who know that they are high risk into the NFIP, and individuals who know that they're low risk out of the market, potentially resulting in an adversely selected pool of participants. And the potential for this kind of selection has been a major barrier to the implementation of pricing reforms, or shifts towards actuarially fair pricing. And so, we certainly want to know if this kind of behavior, this informational asymmetry exists in this market, particularly in light of upcoming potential reforms. So, this is the question. We're interested in determining whether there's asymmetric information about risk in this market. And what we're going to use is the logic of this Finkelstein and Paterba 2014 paper of the unused observables test, where the logic here is that in a symmetric information setting, when there's no cost to doing so, the insurer will and should condition the price of insurance on any relevant attributes. And so insurance contracts in that setting are going to be set based on attributes that are correlated with both demand for insurance coverage and the risk of loss. And so if we find conditional on prices that a buyer characteristic is correlated with demand and ex post risk of loss, then this would imply the presence of asymmetric or asymmetrically used information in this market. And so from the claims data, we can construct aggregate claims probabilities at the tract level for these two different areas. We can also construct average claims normalized by the amount of coverage as two cost measures. And this is just showing looking at what's our unused observable here, what's potentially a good measure of unpriced risk. Well, the first street flood factor in our setting averaged at the tract level by special flood hazard area and non-special flood hazard area should capture or be a good measure of true risk in these geographies. And so, finding what we find is for both of these areas, non-SFHA and SFHA areas, positive correlation between the average flood factor within these geographies and take up, where increasing flood factors indicates increasing risk. So, one condition for this unused observables test for potentially asymmetrically used risk information. On the cost side, we find similarly a positive relationship looking at claim probability. We also find a similar positive relationship looking at claim amount. So based on this unused observables test, suggestive evidence of private information being used or existing in this market, suggesting the potential for adverse selection. So I'm a few minutes over the time that we were allotted. So I'll go ahead and wrap up, and I'm happy to stick around for questions, and also encourage folks, if you have comments or questions or thoughts, to email afterwards. But just to wrap up, we use historical National Flood Insurance Program policy and claims data to examine aggregate demand, both outside and within special flood hazard areas at the tract level. And we find, I think, perhaps most importantly for in terms of the implications for policy, suggestive evidence that homeowners select into insurance based on unpriced risk. We also provide, novel, we believe novel estimates of demand elasticities for these lower risk areas, these non-special flood hazard areas, not subject to the mandatory purchase requirement. I'll go ahead and stop here, but happy to discuss broader implications with folks offline of these findings for upcoming policy reforms. But yeah, I'll stop and say thanks to the First Street folks for the opportunity to share this work.
Wonderful, thank you so much for that, Jake. If folks have questions, I think we can do that now if that's okay with you, Jake.
Works for me.
It looks like we have one in the chat. Can you read that there, Jake?
Yeah, I'm seeing that from Adam Pollock. Thank you for that. It's about the, yes, so in terms of constructing, yeah, so certainly it's a course process that we follow to construct these estimates of the number of housing units within at the tract level for special flood hazard areas and non-special flood hazard areas. We group all A and V zones as special flood hazard areas, and then if a centroid for a census block intersects any of those, then we would count that as within those zones. But I think the general point is perhaps this question is about using centroids. So perhaps you know, a robustness could be to calculate these denominators using some other spatial join, perhaps an intersect might be an interesting robustness. So if I'm understanding the question, sorry if I missed that, but that might be a way to address this concern about overestimating take-up rates. Great. So Kathy Schaefer had a question about changes in take-up rates due to COVID. We actually just got access to the 2020 data. It's not what we analyze in our main sample due to the fact that some of our covariates aren't available for 2020, but we haven't specifically, I've noticed, you know, looking on aggregate, I haven't been looking for this, but in aggregate, our estimate of policies in force on an annual basis for 2020 is lower than previous years. It'd be interesting to see about what might be happening with take-up rates due to COVID. I can't give you anything more than that at this point. I think Jeremy, great point about potentially a proportional intersection. I think these might make for great alternative measures of take up, that is, for folks not following along with the chat. Again, I didn't put my email on the slide, but certainly encourage folks, I'll put it in the chat. Feel free to reach out with comments or questions by email. Would love to hear thoughts. All right, seeing a few more questions. So seeing a few questions coming here. Are risk-based premiums going to solve the debt of the NFIP? It's an interesting question. I think our evidence, particularly on selection, might, you know, we're not estimating structurally demand and cost curves here, but the fact that we do find adverse selection may suggest that that risk actuarially fair pricing may not actually solve these fiscal solvency issues. We may end up seeing an even more adversely selected pool of participants in the market, but I think at this point I could only speculate from our results on that, but it's an interesting question. Okay. I see Carolyn's weighing in there, great. I'm seeing a lot of great comments here. I'm not sure I'm going to be able to respond to all of them. Some more thoughts on our process used to construct take-up rates.
Jake, if you want to take any more of these, go ahead. If not, I think
Yeah,
we
I
have
think
about 15.
I'll hand it over to you since
Okay.
I know you had more planned. But I'll respond to some of these in the chat. Thanks, everyone.
Okay.
Keep them
Awesome.
coming.
Thank you again, Jake, and thanks for your questions, everyone. We have about 14 more minutes scheduled. I think we have enough time for Jeremy to give his high-level overview of AAL, and then folks can ask questions as they come up.
Yeah, thanks, Jake. That was a great presentation. I actually like the idea of having a longer format. We can get into the presentations a little bit more, so maybe we can do that in the future. And then my presentation was intended really to be filler because we did have somebody that dropped off. So I'm really just going to cover what we've done to produce our AALs, and then the national report that we're going to put out in a couple of weeks. We have some national insights from that, so I can cover that pretty quickly, answer any questions, but it definitely won't be as in depth as what Jake was able to present here in his presentation. So I'm going to share my screen. So I just shared in the chat. I suspect most people have seen this, but the Congressional Research Service just put out this report. From my reading, Carolyn, Jake, other folks on here there may be some other resources that exist, but to my understanding, this is the most comprehensive public comparison of the risk rating 2.0 versus the current NFIP structure, pricing structure that exists. It does a really good job of sort of getting people up to speed on it without actually opening up a lot of the things that are still sort of undercover and not being released as part of the 2.0 release. But I put it in the chat a little bit, maybe the fourth message up. So if people haven't seen it, I think it's definitely worth reading. So we at First Street were, excuse me, embarking on the creation of an average annual loss for all properties that have risk. This came from our initial national report, where when we highlighted risk relative to FEMA SFHAs, a lot of the feedback that we got back from homeowners, from the press, not necessarily from academics and researchers, because you understand the sort of relationship between risk to the footprint and damage. But a lot of folks were essentially saying, what does this mean for me tangibly? You have a 1 to 10 risk score. You give me some depths of water, but what does it mean in terms of my my property value? So ultimately, we wanted to produce something that people could sort of wrap their hands around, something more tangible. So we produced this average annual loss. Excuse me. As part of that estimate, I mean, we've been poring over some of the research and the literature and some of the things that folks have said about the economic risk of flooding. One of the things that we were pointing to was Michael Grimm, his testimony to the House of Representatives Committee on Science, Space, and Technology. He points out that between 2010 and 2018, there's roughly $17 billion annually in flood risk. If you look at the NFIP, IA, SBA payouts, this number is much higher than those payouts. So what we're actually doing is estimating damage and not the actual payouts based on the restrictions and conditions that are set against all of those different programs. So our estimation when we're producing these AALs, that we wanted to use this as kind of a target, as something to sort of think about when we produce the results. We expected our results would be a little bit higher, given that this was 2010 through 2018, and there's a moving average across that 8-year window. So we set out to produce an average annual loss indicator. The average annual loss indicator makes use of our flood layers. We're showing here 5 of the flood layers. For those of you that have been in the API, you know that there's more than just 5 different flood layers. But what we end up doing is we create a loss probability curve associated with the likelihoods of flooding and then the depths at those different likelihoods. To understand AAL, we've produced that for today and produced that into the future. So essentially, in a 500-year flood, there's 36 inches of inundation, but in a 2-year flood, there's only 12 inches of flooding. So all of that becomes important as we walk through the AAL calculations. we ended up trying to estimate building characteristics to apply to the U.S. Army Corps' depth damage functions on aggregate. I know Carolyn, Nicholas, Ali recently have written a paper around the utility of these U.S. Army Corps depth damage functions. They tend to be the standard application that we use right now for a generalizable set of depth damage functions, but there are also some problems when you work your way all the way down to the property level. On aggregate, at higher levels, they're fairly accurate because of the data that was used to derive the curves, but at a property level, we know there's some uncertainty associated with their applications. That being said, there's a few things that have to be understood for the application of these U.S. Army Corps depth damage functions. Potentially the most important is first floor elevation. First floor elevation gives us the ability to understand if the water to the building footprint actually enters the home and causes damage. There's a couple other things that are important, whether there's a basement or not, what flood zone you're in, whether it's riverine, pluvial, coastal A or coastal B. Those different indicators give us different curves along with the different building types. So we ended up using the Lightbox parcel data, which gave us a lot of information about 60% of the properties in our database. So we still had about 40% of the properties that we were missing data on. If you've used parcel level data, you know that tends to be geographically localized where the data is missing. So they oftentimes come from county assessors offices. So it'll be missing at the state level or at the county level. So there's lots of holes in the data. We had to figure out ways to plug in estimates or default data where we didn't have the data. So for that, we ended up using the National Structures Inventory data at the census block level. And our expectation was that by using that at the block level, we could get a good understanding of what the building codes were in the area. We could take the modal response on basement, the average response on first floor elevation, the average response on number of stories, number of units, those kind of things where we were missing data, we could get a typical home within that census block. And census blocks, again, everybody probably knows that on this call, are about roughly 150 homes or so. So it gives us the ability to understand in a small area what the typical home looks like. And where we had missing data, we ended up using that and plugged that in for our building characteristics. One important thing on the depth damage functions is we spoke to Adam, just had a message pop in. We did end up speaking with Will, who actually created the U.S. Army Corps data. The basement and first floor elevation data he mentioned the same thing, that it's potentially problematic to pull the data directly from the NSI. We ended up doing a lot of training of the data sets where we do have data. And then we ended up having to check. We checked a lot of our parcels against parcel data that we have now against what the NSI was showing us as ways to understand where we might be off and where we wouldn't be. Ultimately, I'll show you in a minute, we ended up integrating this on flood factor. We're going to integrate it with a calculator. So we're going to give people default settings, but we're going to give them the ability to adjust their first floor elevation, to adjust their number of stories, whether there's a basement or not, so that the curve application will be appropriate for what they're doing or for their home's characteristics. But the U.S. Army Corps is a percent based, so that they would be generalizable. So we ended up meeting to produce a structure value. So we're partnering with a group called House Canary, which is a lender grade automated value model company. They can give us a high quality indicator of the property value. We know the depth damage functions are only appropriate for actual structural values. So we ended up proxying that with the improvement percentage from the assessor's office to get an understanding of what the property of the actual building is versus the overall property. And that then gives us the value to which we would apply these damage percentages to. So once we were able to do that, we know the number of inches for any property at any return period. We end up subtracting from the impacted area or from the inundation in any of these return periods, the height of the first floor elevation. which leaves us with the amount of water inside the building. And we use then the depth damage functions to produce an indicator of damage for that depth of water. When you do it for the different return periods, only 4 of them are shown here. The 1%, the 10%, the 20%, there's only 18 inches of water. The house is raised 24 inches off the ground, so it would leave 0 inches inside the home. So we ended up with 0 inches or $0 in damage. We ended up multiplying each of those by the return period, by the probability, adding those up. And again, this is a simplified example, but this then would give us our expected average annual loss. So we took this approach to produce the average annual loss. We know it's a simplified approach. We're using curves that have a lot of uncertainty around them at the property level, but they give us the ability to start to quantify the risk indicators that we first produced in the flood factor national release from last summer. Once we did that, one of the things that is really interesting to us and interesting to a lot of people here is that risk rating 2.0 is coming down the pipe as a risk-based pricing structure. So it gives us the ability to understand risk in a more AAL industry standard approach versus what the current pricing structure is. And so we ended up going through the NFIP's rating manual, pricing insurance manual. We repriced NFIP premiums for all the properties in our data set with the conditions that we would max out their coverage up to the cost of their building structure, capped at $250,000, and that we would have a $1,000 deductible. So there's no discounts on premiums for deductibles. And our goal was, by doing that, to try to produce an expected NFIP premium as close as we could to the AAL approach, where our AAL approach doesn't have discounts under $10,000 in flooding. It maxes out at $250 for comparison purposes. And we wanted to start to get a feel for what an economic risk structure today, a pricing structure, might look like relative to an NFIP premium pricing structure. So it's really a theoretical comparison of our AAL approach versus the current NFIP pricing structure, as opposed to being perfectly appropriate for any given home. So we ended up running that for all the properties in our data set, and at a national level, we're sharing out some data now with some folks that are gonna help to cover the story, and this also gives us some information for our own research purposes. But we've broken down the data by all properties inside the SFHA, outside, and then properties with a 1 in 100 year First Street risk, and then our extreme properties, so the most at risk properties. I can sort of move through this pretty quickly, but the few things that become important here, we have an indicator of average annual loss. So on average, the annual loss for properties in these different categories versus an aggregate view. So remember that Grimm said that there's about 17 billion annually. We come up with about 20.3 billion. We're in the ballpark. We're a few years past that rolling average from 2010 to 2018. So the number makes sense to us in terms of aggregating the total economic risk. The per property risk for only properties with structural damage, we quantified here in column K. We quantified it again with a $250 cap for comparisons later to the NFIP, but we wanted to look at this over time also, so we can see the increases in average risk over the next 30 years. We can see a 60% increase. Again, we're holding adaptation constant, we're holding development constant, we're holding everything constant except the future environment. So we know there's going to be changes to the pricing structure, there's going to be changes to development, to adaptation, to everything, but this just gives us a way to isolate current future environmental conditions. We have our AALs, so these are our building structures on average that we ended up, values that we ended up applying the price to. These are the loss to the structure AVM. So they tend to be relatively low as a percentage of the total value. Again, these are annualized indicators, about 2.5% inside special flood hazard areas annually, about 3.3% for properties that are 9s or 10s on flood factors. And then the NFIP estimates, right, for the 5 different groups. These are the average NFIP estimates from our exercise of working through the pricing process. And this column AG, ends up being essentially the difference, or the gap between what we currently estimate economic risk to be versus what the current NFIP pricing structure is set up to protect against. If it were to be to not be set up to lose money, as Ali always likes to tell me. So the difference here then is about a 4.5 times the difference in economic risk. For all properties, it ended up being about 3.7 times. I know we're running up on 12, 15 people have to run, but we ended up producing a lot of national maps so we could start to understand what this looks like across the country. A couple of them were interesting. Most of this risk, total structural damage, is really focused in Florida. These are county level dot maps where the dots are scaled to the risk indicators. The upper mid-Atlantic area has a lot of coastal risk. AAL is driven by high property values and high probability flooding primarily. So we know these areas end up having a lot of risk. Charleston pops out here in the South Carolina area. There's a couple of interesting charts here. Here's the loss of structure relative to the AVM. Some places pop up where we identified high pluvial risk of flooding, places that are outside the special flood hazard area that generally have the preferred risk policy, if they have any policy at all. Their economic risk versus coverage is pretty high. The coastal areas, again, start to pop out as being pretty high. Change over time is dominated by the Gulf Coast and the Atlantic coast, primarily sea level rise, increasing intensities and of cyclonic events. And then potentially the one that we thought was really interesting, well, 2 of them. The yellow in these bar charts are the amount of risk, economic risk, outside of special flood hazard areas. The blue are inside special flood hazard areas. The shape of the trapezoid going from left to right is change over time. And so we end up then having Florida sort of stands out on its own. It's this huge column. We have a couple of other places where you can start to see where risk is going to change. In South Carolina, almost all the risk is currently in the special flood hazard area and remains in the special flood hazard area. California, we estimate more risk outside the special flood hazard area than inside. So there's different patterns by state. But then when we started to look at the NFIP versus economic risk, the yellow to purple scale show places where there's more risk than the NFIP pricing structure is currently accounting for. The blues show places where NFIP is adequately pricing or overpricing per the economic risk. So the coastal areas sort of pop out. This area around the Appalachian region, a lot of it outside the special flood hazard area, end up popping up. And then we have this belt of blue where it seems like we're adequately pricing risk, or we're actually overpricing risk. And one of the things that the people that we've been talking to, especially a lot of the reporters and the folks that want to make this a story, are thinking about this as subsidizing risk. So they're saying the blue counties essentially are subsidizing the risk of folks on the coast or further inland, and that ends up being then something that the NFIP risk rating 2.0 was hoping to correct for. I think in that PDF, it actually says that there will be no shortfalls in the program. If there's a shortfall that's identified, the pricing algorithms will be adjusted to correct for the shortfall. And they want to move completely away from the subsidy-based approach that's currently set up in the NFIP pricing structure. So being able to visualize, where that's most likely to impact properties and potentially where we've been subsidizing risk up to this point is sort of our the outcome, I think, from this map. Again, it's not what we set out to do. We really set out to quantify economic risk, but it just happened to align really well with the risk rating 2.0 and all the discussions around 2.0 to this point. So I, along with a couple of other folks, have, we're researchers and scientists the same way that the folks on the call are. There are a lot of people at First Street that are marketers that use this data to get it out to tell a story. We want to draw attention to the data. We want to uncover and quantify economic risks. So a lot of these materials have been developed to help us sort of tell that story. So if there are any questions, I'm happy to answer any questions on that also. But I really intended for this just to be a presentation of what we have coming down the pipe. Yes. Yeah. So 1 over the return period is the probability. So we would end up using, for instance, here a 500-year event, a 100-year event, 10-year event, and so forth. We go, for example, you add any other RP, you always. Yeah.
So,
go ahead.
Yeah. So we actually, what's shown on the slide is just kind of a simplification.
Yeah.
This is really what Jeremy uses to show the press who are not as astute with some of these. But yes, so we do average over the space, over the entire probability space between those individual points. So it's not simply a summation.
Yeah.
It is yeah, there you go.
Yeah, so we end up using a traditional loss probability, a curve. Yeah, yeah, Adam, that's a good point. When we explain this to people, we end up ultimately having to create a deck just for the explanation. It ends up, I think that scientifically is not as sophisticated of an approach as actually modeling the data, but modeling the actual flood models, but it's a much harder story to tell, which we're running into with people that we're talking to. It's a story different if you use different spatial units. Yeah, I mean, even within the different spatial units, to Eric's question, there's even more localized and more focused inequality within counties. So if you look at zip codes, for instance, you can see you'll see a similar pattern where at each lower level of geography, there's more of a localized approach moving to the lower geographies. And we're going to make all this data available on the API, but we'll also have aggregate versions of the data, city, county, and zip code level that we'll put up on AWS with our other aggregate data for public consumption. So we'll stop.
All right. Well, thank you everyone for joining us and for sticking around for an extra 10 minutes. If you have additional questions, feel free to reach out on email or otherwise.
Mm-hmm. Yeah.
Cool.
Yeah.
Thank you all. Thank you, Jake.
Mm-hmm. Yeah. Thanks, Jake.